Section 9.5 is on solving quadratic equations using the quadratic formula. And this is the last of 4 different ways that we've looked at to solve a quadratic equation. And this one's really cool because it always works. Even you may not be able to factor a quadratic equation, you may not be able to, graphing it may be difficult, completing the square might get a little messy. The quadratic equation always works. So if ax squared plus bx plus c equals 0, then this is what x is equal to. And you can actually remember this from a song, To Pop Goes the Weasel. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's take a look at a couple examples. So we're going to solve each quadratic equation using the quadratic formula. So I think it's very helpful to start by identifying a, b, and c. A is the coefficient of x squared, which is 1. B is the coefficient of x, which is 2. And c is the constant, which is negative 35. Now, let's just plug those into the formula. So x equals negative b, which actually means the opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2a. And actually, after you've done this a couple times and you're familiar with it, you can probably skip writing out some of these steps and do some of the multiplications in your head. So x equals a negative 2, or the opposite of 2, negative 2 is positive 2, plus or minus the square root of 4, negative 2 squared is 4. I'm thinking of this as negative 4 times 1 times negative 35, which is plus 140, over 2 times 1, which is 2. Continuing just to PEMDAS this, 2 plus or minus the square root of 144 over 2. 2 plus or minus the square root of 144 is 12 over 2. And so this really gives me 2 equations. So I have x equals 2 plus 12 over 2, and x equals 2 minus 12 over 2, or x equals 14 over 2, which is 7, or x equals a negative 10 over 2, which is negative 5. So there are my 2 solutions. Remember, what this means is that if I were to graph the related function, if I were to graph y equals x squared minus 2x minus 35, it would cross, that parabola would cross the x-axis at the points x equals 7 and x equals negative 5. But this is a lot easier to use the quadratic formula instead of graphing. Let's take a look at another example. Let's identify our a, b, and c. A is 1, b is 10, c is 12. Using our formula, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Or x equals negative 10 plus or minus the square root of 100 minus 48 all over 2, or x equals negative 10 plus or minus the square root of 52 over 2. And since 52 is not a perfect square, actually it can be simplified. That square root can be simplified, but I think that's in the next chapter or the chapter after that. We're just going to leave it like this. So these are my 2 values of x. Since I can't take the square root of square root of 52, I'm going to leave it as negative 10 plus or minus the square root of 52 over 2. Realize this is 2 answers. One is negative 10 plus 52, square root of 52 over 2, and the other is a minus. Notice I didn't come up with a nice answer like in the previous example of 7 and negative 5. Here's another example. 3x squared plus 5x plus 11 equals 0. A is 3, B is 5, C is 11. Let's plug it into the formula. So x equals negative b plus or minus the square root of, I'm going to do a little bit of this in my head, b squared. 5 squared is 25 minus 4 times a times c. Okay, I can't do that in my head right away. All over 2a, which is 6. Let's clean that up a little bit. Negative 5 plus or minus the square root of 25 minus 132 all over 6, which is negative 5 plus or minus the square root of negative 107 all over 6. Okay, so let's take a look at this. So square root of negative 107, that's not a real number. You can't take the square root of a negative number. So if you end up with a negative number under your radical sign, your answer is going to be no real solution. There are imaginary solutions, and you'll learn about that in Algebra 2, but there is no real number for this. That's not a real solution. So actually, if we were to graph the related quadratic function, this would be one of those parabolas that would be opening upward, and it would be above the x-axis, going up, and it would never cross the x-axis. So this is what you get. Sometimes you end up with no real solution if you have a negative number under your square root sign. And let's take a look at our last example here. So I have x squared plus 25 equals 10x. In order to use the quadratic formula, it has to equal 0. So I'm going to subtract 10x from both sides. And that's going to give me x squared minus 10x plus 25 equals 0. A is 1, B is negative 10, C is 25. So plugging it into the quadratic formula, x equals negative b, the opposite of b is 10, plus or minus the square root of b squared, negative 10 squared is 100, minus 4 times a times c, all over 2a, which would be 2, or 10 plus or minus the square root of 100 minus 100, over 2, or x equals 10 plus or minus the square root of 0 over 2, which is basically 10 over 2, because square root of 0 is 0. So in this case, I have only one solution. My one solution is the value x equals 5, and if you remember from previous sections, this was a graph where the parabola just touched the x-axis in one point. In this case, it would touch the x-axis at the point x equals 5. And one last thing to look at in this section is called the discriminant. The discriminant is basically b squared minus 4ac. It's the stuff that's underneath the radical. And the value of the discriminant can tell you how many solutions a quadratic equation has. So if the discriminant, if b squared minus 4ac is negative, you're going to have no real solutions. And we saw that in example number 3, where we had a negative number under the square root. There's no real solution. If b squared minus 4ac is positive, we're going to have two real solutions. It might be two integer numbers like we had in the first example, or it might be two numbers that have a square root in them, two irrational numbers like we saw in the second example. So if the discriminant is positive, two real solutions. And if the discriminant, b squared minus 4ac, equals 0, you're going to have one real solution, like we saw in our last example, right up here, where the stuff under the radical ended up being 0. So using the discriminant can help you figure out how many solutions and what type of solutions you have. So let's take a look at a couple examples here. State the value of the discriminant for each quadratic equation, then determine the number of real solutions. So I think I'd like to identify my a, b, and c. A is 4, b is negative 20, c is 25, and instead of doing the full quadratic formula this time, I'm just going to do b squared minus 4ac. That's just the discriminant. So I have a negative 20 squared plus 4 times a times c, or 400. Oh, I'm sorry, my mistake, not plus 4, minus 4. B squared minus 4 times a times c. And 4 times 4 is 16. 16 times 25 is 400. So in this case, the value of the discriminant is 0. And looking back at my previous page, if the discriminant equals 0, I'm going to have one real solution. So find the value of the discriminant, and then tell what that says about the number of solutions. Example number 2, 5x squared minus 3x plus 8. A is 5, B is negative 3, C is 8. So b squared minus 4ac, b squared is going to be 9 minus 4 times a times c, or 9 minus 160. The value of the discriminant is negative 151. Since that's a negative number and that's going to end up under the square root sign in the quadratic formula, I have no real solutions. And my last example, 2x squared plus 11x plus 15. A is 2, B is 11, C is 15. B squared minus 4ac gives me 11 squared is 121 minus 4 times A times C gives me 121 minus, did I do that right? 4 times A times C. Yeah, minus 120. Good. Gives me 1. The value of the discriminant is 1. That's a positive number, so I'm going to have 2 real solutions. So in this section, we learned how to use the quadratic formula. Make sure you memorize that. Sing the song if you need to. How to use the quadratic formula to find the solutions to quadratic equations, and then what the value of what the discriminant is, how to find its value, and then what that tells us about the number and type of solutions.